Hi, fourth grade. It's me, Miss Belts, and we're going to work on math some more. So let's get started. Today, we are going to round to the nearest 10, 100, or 1,000 using compatible numbers to estimate solutions involving whole numbers. Remember last week we worked on rounding, and I told you we were going to work on estimation this week, so that's what we're going to do. How are we going to do this? Well, we're going to review vocabulary. We're going to represent word problems with a strip diagram. We're going to write an equation to represent the problem, and then we're going to estimate. Why are we going to do this? It's important for us to be able to estimate a solution to check if our answer is reasonable or not. So does it actually make sense? So let's look at our vocabulary. Our vocabulary that we have this week, our first word is rounding, and we had this word last week. Rounding is finding a number that is close to the original number by changing it to the closest multiple of 10, 100, 1,000, and it can keep going up. The next word we have is estimate or estimate. And whenever we estimate, it's a reasonable guess that is close to the right answer. The last one that we're going to look at is compatible numbers. Compatible numbers are numbers that are close to the original value and make a problem easier to solve mentally. That's the whole reason that we estimate, so we can try to make a problem easier to solve. So in this example, 102 minus 28 equals something. We round 102 to 100 and 28 to 25 because working with money, we know that 100 minus 25 can give us 75. So we know that the difference is close to 75. So it made it a little bit easier for us to solve. So that is what we're going to do today. We are still going to go through our problem solving process, but you'll notice that that fourth and final step of solve is not there. Sometimes whenever we have problems, we get to stop at the strip diagram because that's what the question's asking. Sometimes we stop at step 2, which is the equation, because that's what the question's asking. For today, we're going to get to stop after step 3 because we are just wanting to estimate for now. And then sometimes there will still be step 4 whenever you have to solve. So let's take a look at our question. Here's what it says. While doing research for a report on Texas cities and towns, Adrian learned that 81,443 people live in Longview and 61,238 people live in Cedar Park. About how many more people live in Longview than Cedar Park? So we're going to look at the important information so we can figure out what our strip diagram is going to look like. Before we do that, I want to talk about this word right here. It says about how many more people live in Longview than Cedar Park. Whenever you see it say about or approximately, that's usually your clue that you're going to estimate because it doesn't want to know exactly, it wants to know about. So let's look at it one more time and find our important information. So while doing research for a report on Texas cities and towns, Adrian learned that 81,443 people live in Longview. I highlighted that because that's important information for this problem. And 61,238 people live in Cedar Park. Again, I highlighted it because it's important information. About how many more people live in Longview than Cedar Park? I highlighted that because that's my question. So now I have to think about what is my strip diagram going to look like? Well, this is a special kind of strip diagram because it's a comparing problem. I'm comparing Longview to Cedar Park. And I want to know how many more people live in Longview than Cedar Park. So when I draw my strip diagram, it's going to look like this. This bar is going to represent Longview. This bar is going to represent Cedar Park. You'll notice that this bar is smaller because 61,238 is smaller than 81,443. I'm trying to figure out this piece right here. That's going to be the difference between the two. So that's how we're going to set our problem up. So I want you to think about it. If this is what our problem looks like, and I'm trying to find this piece right here, am I going to be adding or subtracting? If you said that I was going to be subtracting, you are correct. So my equation for this problem is going to be 81,433 minus 61,238. And I'm trying to figure out what that difference actually is. So now we're going to estimate. So I'm going to write down my equation again. 81,443 minus 61,238. Now, if you think back to last week we used number lines to help us with rounding to decide what the closest number was. And we're going to do the same exact thing. We're going to first start with our 81,443. So the first thing that I've done is I've drawn my number line. I have decided which two benchmark numbers I'm going to use. So I'm rounding to the nearest 10,000s because both of these numbers are in the 10,000s. So 81,443, I'm going to have 80,000 on this side and 90,000 on this side. I'm going to then plot where 81,443 goes. And since it's pretty close, I'm going to put it right there. Then, if you remember back to last week, I'm going to draw my different colors from 80,000 all the way to 81,443. Excuse me. And then from 81,443 all the way to 90,000. So when I do that, that's what it's going to look like. So is 81,443 going to round to 80,000 or is it going to go to 90,000? If you said it's going to go to 80,000, you are correct. 81,443 is close to 80,000, so that means it's going to round to 80,000. And you'll see underneath 81,443 in my equation, I actually wrote 80,000 just so it helps me remember. Now we're going to do the same exact thing for 61,238. So the first thing I'm going to do is draw my number line and I'm going to plot where it's going to go. After I do that, I'm going to draw my lines. And then I'm going to decide, is 61,238 closer to 60,000 or is it closer to 70,000? If you said it was closer to 60,000, you are correct. So that means that 61,238 rounds to 60,000. And again, you can see that I filled in my equation. So now for my estimate, I'm going to solve 80,000 minus 60,000. So think about it. Is 80,000 minus 60,000, what is that answer going to be? There's a couple of ways you can solve it. Maybe you already know what 80,000 minus 60,000 is. Maybe you want to use a number line to help you solve. Maybe you want to use base 10 blocks or expanded form. Whatever form makes it easier for you to solve is completely fine. So if I do 80,000 minus 60,000, I end up with 20,000. So that means that about 20,000 more people live in Longview than Cedar Park. Let's try another example. So let's look at this one. This one says, oh, I forgot to change my number. A toy factory produced 35,687 toys in January, 32,146 toys in February, and 33,456 toys in March. About how many toys did the toy factory produce in all 3 months altogether? So you can see I've gone through and highlighted the important information. January was 35,687. February was 32,146. March was 33,456. There's that word again, about how many toys did the toy factory produce in all 3 months together? Remember, this word about tells me that I don't have to actually solve it all the way. I just have to estimate. So the first thing I'm going to do is my strip diagram. I know that I have to put all 3 of these together. So when I do that, my strip diagram is going to look something like this, because I'm joining all 3 of these numbers together, and then down here at the bottom, that's going to give me my total. What is my equation going to look like? If you said I'm going to add, you are correct. So I'm going to add 35,687 plus 32,146 plus 33,456. So the first thing I'm going to do is I am going to draw my number line for my 35,687. I'm going to plot it, and I'm actually going to draw my lines from one of my benchmark numbers to 35,687, and then 35,687 to my other benchmark number of 40,000. Now, which one is this closer to? It's kind of a tricky one. If you said it's closer to 40,000, you are correct. It's just barely closer to 40,000 because it's close to in the middle. And remember last week we learned that if it's in the middle or close to being in the middle, it's always going to go to the bigger number. So again, I wrote down my answer right here. So 35,687 is going to be closer to 40,000. So now I'm going to do the same thing for 32,146. So again, I have plotted my number, I've drawn my lines, and I can see which one it's closer to. So which one is it closer to, 30,000 or 40,000? If you said 30,000, you are correct because it's closer to 30,000 than it is to 40,000. I'm going to do the same exact thing for my last number of 33,456. I've plotted my number, I've drawn my two different color lines, and I can see which one it's closer to. So which one is it closer to, 30,000 or 40,000? If you said 30,000, you are correct. So now here is my new equation I'm using, 40,000 plus 30,000 plus 30,000. So when I started thinking about how to solve this, I was able to see that 30,000 and 30,000 was going to give me 60,000. So I am now left with 40,000 plus 60,000. So what is 40,000 plus 60,000? That's right, it's about 100,000. So that means that about 100,000 toys were sold in all 3 months together. So, oops, too far. Let's review what we talked about today. We talked about that we are going to round to the nearest 10, 100, or 1,000 using compatible numbers to estimate solutions involving whole numbers. We reviewed vocabulary. We represented word problems with a strip diagram. We wrote an equation to represent the problem, and we estimated. And the reason that we did that is because it's important to be able to estimate a solution to check if our answer is reasonable or not. So now it's going to be your turn. You are going to use the problem-solving model to represent and solve word problems. Make sure that you read the word problem, that you draw a strip diagram, that you write the equation, and that you estimate. This is what your page is going to look like. So at the top, you're going to put your name, and you're going to put your teacher so I know who to give the paper back to. You're going to read the word problem, you're going to do your strip diagram, your equation, and then I gave you a lot of space for you to do your estimation. You can use the number lines to help you if you want to show me that visual. If you already know how to do it, then that's fine, but make sure you show all of your work so I can see how you are doing your problem. If you have any questions, please ask your teacher. I'll see you next week. Bye.